Now question is based on the increasing and decreasing, and there is a composite function out here. Fx is e raised power x minus x and gx is also given to us. Now let us see again an easier one. H of x is equal to f of gx. Now to find the interval in which hx is increasing or decreasing, we need to differentiate it. So I am differentiating here. So let us see what we are having. H dash x is equal to g dash x into f dash of gx. You can easily see, and what is g dash x? You can calculate from here. This is 2x minus 1, and again f dash of gx. Fx is this, the derivative is e raised power x minus 1. Now substituting with gx, we have e raised to the power x square minus x minus 1. So this is the derivative, that is h dash x. Now calculating the critical points here. What are the critical points? The points where the derivative is becoming 0, it is 1 by 2. And this will become 0 at x equal to 0 and 1. So putting anything beyond 1, that means the sign of this h dash x will be positive here, and definitely there will be a change at 1. The derivative is becoming 0 at 1, and again it will be positive, and here again it will be negative. So the function is easily seen that it is decreasing in this part, again increasing here, and again decreasing, and then again increasing in this part. So the interval in which the function is increasing at 0 to 1 by 2, and again from 1 to infinity. So the option which is correct here is option number 3rd. Next question is again from algebra. Quadratic equation alpha beta are the roots of this equation, and we want to find out the value of this expression in terms of theta. Now this expression seems to be complicated, but it is actually not, and we will be using the concept of sum and the product of roots. So from here, this equation is having roots in variable theta. The sum of root, that is alpha plus beta, from here is equal to minus sine theta, and the product of root, that is alpha and beta, from here is minus 2 sine theta. Now we want to calculate the value of this expression. If you see here, this is 1 upon alpha raised to the power 12, and this is 1 upon alpha raised beta raised to the power 12. So if you simplify this, you will have alpha 12 into beta 12, and the denominator, it is alpha minus beta whole raised to the power 24. Now the product of alpha and beta is here for us, but we want to calculate the difference of root, and you know the difference of root, that is modulus of alpha minus beta, is given as alpha plus beta whole square minus 4 alpha beta. So we can calculate this value from sum of roots. Sum of root is equal to definitely minus sine theta. So we have sine square theta here minus 4 alpha beta. So this is plus 8 sine theta. So the difference of root is here for us, the product of root. So just putting the value here, this is 2 raised to the power 12 sine raised to the power 12 theta, and again substituting this value in the denominator, we have sine square theta plus 8 sine theta raised to the power 12. Now if you take sine common from here, you can easily see the option which is correct is the 4th one. Let us move to the next problem. We are back to calculus, a question from differential equation which was actually missing. Now the question is again simpler. It is based on the linear differential equation. The equation is given dy by dx is equal to 10x minus y secant square x, and the value of the solution at 0 at x equal to 0 is 0. We want to find out the value at x equal to minus pi by 4. So, let us first solve the equation here. If you make the product, we have dy by dx. Now, you have to simplify it first. This into secant square x minus y secant square x. Now, if you bring the second term from the right hand side to the left hand side, you can easily see this is a linear differential equation. This is equal to 10x into secant square x. Now, you can see this is the linear differential equation, and the integrating factor here is e raised to the power integral of secant square x, which is equal to 10x. So, e raised to the power 10x is the integrating factor. Now, the solution is, we know from the result, it is y into integrating factor, that is e raised to the power 10x, is equal to the integral of integrating factor, that is e raised to the power 10x, into this q, that is tan x into secant square x dx. Now, this integral needs a substitution, a very small substitution. If we are putting tan x equal to t, you can see the derivative of tan x is secant square x. So, by putting tan x equal to t, you can see this integral will be e raised to the power t into t, and this term will become dt. So, integrating this, integration by parts. So, it is t into e raised to the power t minus t. So, finally, the solution for us is e into tan raised to the power tan x into y is equal to t. Now, t is tan x, again replacing with tan x minus 1 into e raised to the power tan x plus the integration constant c. Now, we need to find out the value of c. It is given that at x equal to 0, y is 0. So, by putting x equal to 0 here, you can notice y is 0. So, you can calculate the value of c from here. If you calculate the value of c from here, let us see what we are going to get. So, let us understand this one. Simplifying again, I am writing this as this plus c e raised to the power minus tan x. Now, by putting x equal to 0, we have y 0, it is given to us. So, from here c will be equal to 1. So, finally, we have y is equal to tan x minus 1 plus e raised to the power minus tan x. So, the value at minus pi by 4, we have to find out the value at minus pi by 4. At x equal to minus pi by 4, that will be equal to minus 1 again, and this will be minus, that is plus 1. So, it is equal to e. So, finally, the value is e minus 2. So, let us see what is the result we are having here. We are having the result, the option which is correct here is the third one, that is e minus 2. Let us move to the next problem.